So today we discuss about JVM memory diagram. JVM memory diagram. MEMORY diagram. So what is the full form of JVM? JVM means Java Virtual Machine. Java Virtual Machine. What it will do? It will do the source code which is written by the programmer. It convert it into the machine understandable code. Okay, this is done by our Java virtual machine. So it have some logical memory diagram, some logical memory diagram. Let us discuss about the JVM memory diagram. So first of all, we have to know what are the four parts of JVM memory diagram. So assume that this is our JVM. This is our JVM. Okay, this is our JVM. So in JVM there are total four logical part. 1, 2, 3, and the last one is 4. So one part is called as stack, S-T-A-C-K. One part is called heap, H-E-A-P. One part is called static pool area, static pool area. And the last one is called method area, M-E-T-H-O-D area, A-R-E-A. So in each of the part there are some significant or they are doing some work. So first part in stack, the first part was stack. What it will do? The stack is used for, it is used for execution. It is used for execution. E-X-E-C-U-T-I-O-N. So stack is used for what? Stack is used for execution. Now the second one is heap. Heap. Basically heap is used for what? Heap is used for to store, to store, to store non-static, non-static, S-T-A-T-I-C, method and variable, method and variable. To store non-static method and variable, JVM use heap. Then the third one is static pool area. The third one is static pool area. Here in static pool area, all the static data member means method and variable will store. Okay, will store. Method and variable will store. And last one is method area. What is done in method area? Method area, in method area, the method body or definition will store. So method body and definition will store in method area, method body or definition. But method head will store in, if the method is static, then it is stored in static pool area. If the method is heap, non-static, then it is stored in heap area. Okay. So in our JVM logical memory diagram, we have four parts. One is stack, second one is heap, third one is static pool area, and the fourth one is method area. In stack, it is used for execution. Heap is used to store non-static member or variable, data method or variable. Static pool area is store static method or variable, and the method area will store method body or definition. Now we understand by one program how it will store and how the Java program will execute. So first we know we have to take one Java program. So in Java program, class is mandatory. Okay, so we take a class, simple class name was sample, SAMPL. Okay, so first curly braces open and the class curly braces close. In the class sample, we take one non-static int x is equal to 100 variable. Okay, so we take one non-static variable and we assign it with 100 value, and we take one void type of method, add method, and simple we print hello on this add method. Okay, we print hello on this add method. Now we go for our public static void main function. Public static void main function string args. Okay, curly braces open, main function curly braces open, main function curly braces close. In this public static void main, we simple call this variable and this method. Okay, so if we want to call this variable, we have to create a object. We have to create an object. Because why we have to create an object? Because if we call something from non-static to static, then we have to create an object, you know already. Okay, so this is non-static and we call it from a static type of method. So we have to create object. So how we create an object? By the help of which operator? By the help of new operator. By the help of new operator. By the help of new operator and the constructor. The constructor name is the same as the class name. So new plus sample constructor. So this is the object name. This is the object name. Okay. So in this object name, with this help of object, we call this x variable. We call the x variable with the help of dot operator. Okay, dot operator. So we call x and now we print it by system out dot println function and then semicolon. Okay, so here the x variable we print. Now we call the add. So before calling the add, we have to create another object, because without object we cannot call the non-static. So just we create another object new with the help of new operator and sample constructor, and then we call it add method. So here our program is ready. Now we understand how it will store in JVM memory diagram and how it is called by the JVM, how it will execute by the JVM. Okay, so first what we'll do, we draw our JVM memory diagram. So it is our JVM memory diagram. It is our JVM memory diagram. Okay, now I will take a shape. Which shape I will take? This is our JVM memory diagram. Okay, this is our JVM memory diagram. And this JVM memory diagram, we have four part. We have four part. One part is what? One part is this one. Second part is what? Second part was, oh, okay. So this is our first one, first part. Then the second one is, we take this one, our second part in JVM memory diagram, and then we take another one. Okay, this is our fourth one. This is our fourth one, and this is our fifth one. Okay, so this, now it is our stack. It is our stack. It is our heap. It is our static pool area. Static, STATIC POOL, area, AREA, and it is our method area, METHOD, method area. So in our JVM we have four logical area or four logical spaces. One is stack, which is used for execution. One is heap, which is used to store non-static member, which is static pool area, which is used to store static member, and another one is method area, which is used to store method body or definition. Now first, which will come to execute? First our class loader will come. First who will come? Class loader. Class loader. Class loader will come, and what it will do? It will load whole the class in our JVM memory diagram and store the static member in static pool area. So what class loader will do? It will generally load whole the class in our JVM memory diagram, and only the static member, which one is static here? Main method is only the static member here. So main method head will store in public static void main method head will store in static pool area because it is a static member, and where the its body will store, in our method area because method area is available for the method body. Okay, so here the method body will store. So class loader will load the class at a sort and then store the static member in static pool area, and the method body will store in method area. Okay, now JVM will come. Now who will come? JVM will come. Okay, now JVM will come. Now our JVM will come, and what the JVM will do? JVM, Java Virtual Machine. JVM will come, and what it will do? JVM will do JVM will do JVM start execute. JVM execute from our main method. So JVM start execute from our main method. Okay, from our main method or public static void main method. Okay, so the pointer is now in our main method. JVM start execution here. JVM start execute here. Okay, so JVM, when the JVM start executing from our main method, then first JVM will execute from our main method. So pointer go inside the main method. So the first line it will stuck here SOP function, and you know Java is execute from which to which, from our left to right. Java is execute from our left to right. So SOP function will call, okay, system out dot println. Inside the SOP function, first which will get stuck the new operator. You know, new operator is used in Java to create random memory space. Create random memory space. Random memory space in where? In heap memory. In heap memory. So new operator will create a simple random memory space in our heap memory first, then the sample constructor. So what constructor will do? Constructor will initialize all the non-static member in the particular class. Constructor will do, in this constructor will do what? Constructor will do, it is used to initialize all the non-static all the non-static member of the class, of that particular class, of that particular class, of that particular class in our, where? In our heap memory. HEAP, heap memory. In JVM heap memory. Okay. In JVM heap memory. In JVM heap memory. Okay. Now, understand. Now, new function create random memory space in our heap memory. Sample constructor is used to initialize the non-static member. Which is non-static here? The x variable is non-static and the void method is non-static. So these two is initialized in our heap memory on the new operator created by the new operator in this memory space. So x is equal to 100 is initialized here, and the add method signature or the head will store here. Okay, head will store here. So add method signature or the head will store here. Okay, now add method body will store it in where? Add method add method body will store it in where? Method area. Okay, method area. Then dot operator is here. Dot means what? And this memory space is represented by blue color object new sample, SAMPLE. Okay, this object. And inside this object, dot means what? Dot mean inside. Dot mean inside. Inside. Okay, dot means inside. Inside this operator, inside this memory space, we have to pick the x value because we call the X. So X is available here. Simple we print it. Simple this line is executed by the JVM. Okay. The first one is executed. Now in the second line pointer is come. Okay. In the second line pointer is come and it will stuck by another new operator. Another new operator, what it will do? It will do the same thing what the first one will do. New operator create a random memory space, then new operator, what it will do, then new operator will create a random memory space and sample constructor is used to initialize the non-static member function of the particular class in heap memory. So here is also the non-static member is X and add method. Okay, so add method body will store it in method area. Okay, add method body is store it in pink color. Add method. Okay, add method add. Okay, so this object space is represented by pink color object. Okay, this memory space is represented by pink color object. Okay, pink color object. This memory space is represented by the pink color object. New add. Okay, new, not add, it is new sample. New sample is MPLE. Now we have one dot operator. Dot means inside. In Java, dot means inside. So we have to go inside the new sample operator, and inside the new sample operator we pick the add method. Okay, so add method is picked by the JVM, but where is the body of the add method? The add method body is here. Okay, add method body is here. So add method body is executed by this JVM and the whole program will run through this process. Okay, so first class loader will come, and class loader what it will do? It will load whole the class at a shot and store the static method in static pool area. Okay, static method in static pool area or static variable in static pool area. First the class loader do, then JVM will come. When the JVM will come, it will start execute from our main method, public static void main. It will start execute our main method. When the main method is executed, the pointer goes stuck in the next line and the SOP function is called. SOP function, under the SOP function, new operator is here. What the new operator will do? New operator create a random memory space in our heap memory and created this new operator by this memory space, and we have followed by new operator we have one constructor which is same as class name. So this constructor will use to initialize all the non-static member of that particular class in the heap memory. Used to initialize all the non-static member. Non-static member means what? Method or variable. Okay, non-static method x is equal to 100 and variable now x is equal to 100 and method add. So it will store in our heap memory. Okay, so new sample will create a random memory space and then store it in our heap memory. It will done by our new operator and constructor. And dot means inside, then x will execute it and same as the next line. Now you understand what is JVM memory diagram and how it will work when we execute a Java program. Thank you. Like, share and subscribe. Thank you.